So, question number 1. What was the homework? It was
Locally?
It was store load.
No, we didn't have to do store.
He said we had to do it, but then he took it off the
Really?
assignment.
Oh.
I did this.
But I already did it.
No, I think you had to do store.
The assignment, the actual assignment though, you forgot to put that
I
on
didn't
there.
write down, subtract, and multiply, so I was gonna not even do those, but I was gonna do load, and then I checked, and so then I all just.
No, I expected store to be on there.
Well, don't take points off.
We're in 548.
Oh, whatever. So where's did I put like a starting point up here? This is our starting point?
Yeah.
Yeah, right here. It says write store.
Yeah. So like that, you said that in, but on Blackboard, the actual assignment didn't have store.
Oh, whatever.
But I still did it, so.
Okay. Actually, let's go ahead and I'm going to create a new we're going to call this guy Mips. What is it? Mipzy, like that?
Oh, I think it's ZY.
ZY? All right, so I'll go ahead and paste this in as a starting point, and let's get this guy here set up. So we started going through this last class, so we saw that we have two different kind of places. We have fast memory and we have slower memory, which is our data memory. So we are representing these two things in Scheme, and all of our functions that are operating for our MIPS processor are operating in terms of either this register file or the data memory, right? That's what they operate on, those things. All right, so it's going to be in our best interest to make sure we have some good tools available for reading from a register file and writing to a register file and reading from a data memory and writing to a data memory. Before we start writing anything else, we want to have good tools for working with those things, right? All right, so we said register file looks like this. Data memory, for this example at least, looks like this. Once we get to the I/O stuff, we'll actually have to expand our data memory some, because the way MIPS works is with a very specific memory address. Like you get something into a certain memory address and output happens. You get something into a memory address and input happens. So, but for right now, we won't have to change our code much. We'll just have to expand what this guy has in it. All right, so let's focus on the register file here first for a bit. All right, so we have, and one of the things, so I mean, first of all, this assignment is supposed to be hard, right? Now, hopefully as we start going through this, it's not going to seem as difficult as it actually was, but that's always the case, right? Now, this is almost like the ultimate example of solve the little problems first. Because if you try to just build a processor in Scheme, you're going to freak yourself out. All right, so we need to deal with little tiny functionalities, and that will make everything else a lot easier. So one of the things we're looking at here is this idea of a register file. Now, at the end of the day, what is a register file? A register file is name-value pairs. This is the name of a variable, T0. This is its value, 0. This is the name of a variable, T1. This is its value, 0. So on and so forth, right? So what we're really doing here is when we want to get a value from our registers, we're asking for, give me the value of T1, or give me the value of T2, so on and so forth, right? Okay, so we need to be able to search through this. So let's write that function. We want to write a function that will retrieve the value from the register. So maybe we write a function called define, maybe get reg value. and this guy is going to be a lambda, and he's going to take in the name of a register. So we'll call this guy reg name. So given a reg name, he's going to go through our register file and correspond. So for example, if I were to pass in T2 here, let's just close this here, and I were to call, if I were to say get reg value T2, like that, I would expect it to go through and ultimately give me that 0. Okay? That's what I want this dude to do. Okay. So, what is our register file? Our register file is a list which contains a bunch of to-lists, where each to-list is a name, variable, or name value pair. So I want to go through each element of that list, ultimately trying to return a value. Now, maybe we return false if we can't, if we've run out of stuff to look at. So maybe we say if null register file, if I've run out of places to check. What do? Well, I got no value for you. I've run out of places to check. I looked for whatever reg name you told me here, and you either gave me a bad variable name or that's not a register, something like that. So this is our bailout. This is our, hey, the value's false. Move on with life. Ask for something better next time. Otherwise, if I'm in this else here, that means I know that we can take the car of register file, right? Now, register file up here is this global variable. So this is like our starting point for this guy, right? This is what he looks like. But I'm going to need to pass him in to get register value. So get register name from reg file, something like this. So really, we're not asking about this global variable here, reg file, even though that is where this dude came from. And you'll see how the set bang stuff will work here in a few minutes. So really, I'm asking, is reg file null? Whatever was passed in to my get reg value, I passed in a register name and the file I'm looking in. And that file will be in this format, because that is going to be the guy I pass in. Okay? If I'm out of places to look, return false. Otherwise, I want to know if the car of, so in this otherwise, if I say car of reg file, what kind of thing is that going to give me? If this is reg file right here, the car of this guy will be that, correct? I actually want to look at the car of that guy. I want the car of the car. Okay? So we can say, give me the car of the car if we want, using the shorthand like that. Or we can say, give me the car of the car. It says the same thing. So the car of reg file will give me things like 0 or T0 or T1 or T2, those types of things. Make sense? That's what this code right here will produce for me. So now we're asking the question, if EQ, that dude, and the register we're looking for, missing a parenthesis here. If that's true, if the car of the car is the register I'm looking for, I want to return that value, which is the car of the car, well, car of the cooter of the car. So this is the car, the cooter of that is this list, and the car of that is this 0. So if I found a match, I'm going to return the car of the cooter of the car of reg file. That's what I do if I found it. Otherwise, so I take the car of reg file that gives me the to list. I take the cdr of that gets me the list containing the second element. I take the car of that gets me the second element, which was the value. Make sense? So just to go through that, this is the car. The cdr will be that list. The car of that will be that value. Okay? That's if I found a matching register. If I didn't find a matching register, then I want to boil down to get reg value, passing it the same reg name, and passing it the cdr of reg file. All right, that makes sense? Now, what I might do for this is I might call this guy get reg value helper. And I'm calling get reg value helper. And then I'm going to define get reg value to be a lambda that takes in a reg name, and he will call get reg value helper with the reg name and the name of my register file, which is this global guy here. So he just automatically passes in the correct thing for me. All right, so get reg value only requires the user to pass in the register name that he wants to get the value for. What does that guy do? He calls the helper function passing that identical register name. And because we're implementing a MIPS processor, MIPS knows that his registers are stored inside of the register file. So he's just passing that along to this helper function. So this guy takes 2 parameters. Here are those 2 parameters. Okay. All this should compile, right? Well, I have extra stuff to, so let's see, will that let me do that? Or just, I'll just comment it out for now before I go and write it. Okay, so now I should be able to type in get reg value, and I'm searching for like 0 or T0 or T1. So get reg value T0, and that gives me my 0. Here, let's just for the sake of, let's make T2 like a 4, just so we don't have a whole bunch of zeros for testing. And what I do, T2, and there's our 4. Okay, so now we have a way of extracting, and I can say get reg value 0, and that'll give me that 0, because we do have a single, all of our registers start with that T, except we have that base register called 0 that we use to kind of get the ball rolling when we need to like get an immediate value of 2. We use add I with like the 0 register and a 2, and that gives us a 2 to work with. Okay, so this allows us to look stuff up in our registers. So this tool right here allows us to get the value of a register. All right, now another thing we're going to want to be able to do is we want to be able to update the value of a register. Okay, and this is where things get a little bit more sketch because we're having to mess around with the whole set bang thing, right? All right, now when we want to change the value of a register, that means I'm going to go through my register file, find the variable name, the register name I'm looking for, and ultimately, as we would think, change the value at that location. But the reality is what we're actually doing is rebuilding our register file, keeping everything we don't intend to change, and making our one change in that one place. That make sense? All right, so let's do this call it the more direct way, and then there should be actually kind of a fun map way of doing that. Oh yeah, map for that's awesome. Oh, you're gonna hate that. Okay, so let's write it the human way first. All right, so we're gonna call this set reg value, and let's call it set reg value helper, just to kind of follow our model that we did before. And this guy is going to be a lambda that takes in a reg name, a new val, and a, what do we name it up here? Reg file. Okay. Reg file like that. All right, and this guy's job is to update reg file with reg name being equal to this new value. All right, so we are going to be building up another list of lists. So we're going to be asking the question, if null reg file, if I'm out of stuff to check, what are we going to do? We're going to boil down to the empty list. Otherwise, what are we going to do? We're going to ask the question, if the car of reg file, if that guy is equal to reg name, if it's the register that I'm looking for, I need to make a new value for that guy. So the car of the cooter of the car is no longer the accurate value. I want a new toList. So I want a list that is made up of the reg name and the new value. Okay, so that will give me a toList. So this will be a list of two elements where the first element is the register name, because I know I found it, right? And the new value that guy should be, completely disregarding whatever the old value was. So that's what this gives me. And what do I want to do with that? I want to cons that onto whatever is returned by set Reg Value Helper for, well, actually you can make this even simpler. Let's just do it straight cons. You could actually use append here to make your life easier. But this will be, I think, the easiest to understand. So I'm going to cons that onto whatever set Reg Value Helper returns for the same reg name, keeping in mind that we know how register files work, and we already found the guy we're looking for. We don't really need to keep working anymore, right? But we'll let it go through the motions and do its thing and never find it again and just keep whittling down. That's not going to be the end of the world. So we'll cons my new toList with the updated value onto whatever set Reg Value Helper returns for reg name. We can pass in new value here, but we could just pass in LOL if we wanted to, because we know we're never going to use it again. And the cooter of reg file. So I'm going to cons my updated toList onto whatever set Reg Value Helper returns for everything else. That's what I'm going to do whenever I am looking at the guy that I already had. When I'm not looking at the guy I was trying to update, I'm just going to cons the car of reg file onto whatever set reg whatever returns for the rest of it. So the first guy is not the variable I want to change, so I will just keep that toList. And I will cons that unchanged toList onto whatever set reg value helper returns for the rest. All right, so that should be set reg value helper. Now, if we don't want to do error checking, we don't have to check to make sure the register existed. We can just assume that, hey, if you want to change something, give me a register that exists. No harm, no foul. So let's go and write our actual value here. So set reg value. I'm going to just steal that first part of it there. So we're going to, actually, did I get to define? Yeah, I did. So we're going to do set reg value. And this guy's going to take in a register name and the new value. And what he's going to do is he is going to, well, let's just start with our call. So he's going to be calling set reg value helper. Passing it our register name, our new value, and, well, I guess I can put this all on one line so it doesn't get too, register name, new value, and then the name of our thing is called register file. Okay. So for right now, let's say that that's what that guy should do. All right, so we pass it the register name that we want to update and the new value. He will call our helper, passing it that register name, the new value, and the register file he should be updating. But now when all is said and done, we want register file to now be equal to that new value. And how do we do that? We say set bang register file equal to the result of, I'll go ahead and kick it down now. That. So I'm going to set a register value, whatever register name, whatever the value I want to set, and I'm going to be updating an existing variable. My existing variable is called register file. And I'm updating it by I'm setting it to a new value. What is the new value? Whatever value is returned by set reg value helper for my register name, my new value, and the current version of register file. Okay? So let me go ahead and switch this back to a 0 here. And then for right now, I'm going to go ahead and let's just display register file. That'll output what our current register file is. Then we're going to call set reg value. And we're going to pass it our register name. So let's change T1. Let's change it to a 5. And then we'll display register file again afterwards, which should have an updated T1. So all our registers should be 0 beforehand. Now our registers should all be 0 except T1. It should now be a 5. What do I call it? New val? New val. At least I'm consistent. All right, there's my original. What I changed? I changed T1, T1 used to be a 0. Now T1 is a 5. All right, make sense? All right. So now we have a tool that can read from our registers and write to our registers. Make sense? Is that a pretty powerful tool for us? Okay, that's a helpful tool that will leverage a lot as we go and write these other things. All right, now, if we want to, because what we could have actually done, let me try writing it down here. Let me just get the name of this. Well,
Is there a way that we can do that without using cons? Like, can't we just overwrite?
well, sort of. Let me show you a couple of things here. One thing we could have done that will just change it a little bit, I'll just point out, I won't actually make that change, is in this case here, when we did find the guy we want to change, that's our change one, right? Set, yeah. When we did find the guy we wanted to change, I'm consing, well, instead of a cons, I would append. I would append the list of this guy onto the cooter of reg file. So I could rewrite this right here to say list of that append, and then instead of calling this recursively, I can just say, I know I'm not touching the rest of this, so just leave it as is.
Can you scroll up?
No.
So what I was kind of asking is that you can't just keep going all the way to the register file. You can't just like, let's say you want to change the 0, which I don't know if you can.
You want to change this guy? Can I just go in and just change this one piece of this thing? No.
No, you can.
Yeah, you got to build a new list. So there's our same result as we had before with fewer recursive calls. I mean, effectively what I just did by putting the append in there, I just said I'm not going to waste time with more recursive calls because I know I've already updated my variable. I've updated it right here. So there's my updated to list. So what I'm going to do is I'm just going to artificially wrap that to list in its own list. So now I have a list containing a to list. And the only reason I'm doing that is to package it for append. Because what append does is it glues two lists together. So this will take the contents of this first list, which is just my to list, and put it with the contents of the cooter of reg file, which is a bunch of other to lists that don't need to be changed. That make sense? All right, so now let me try to write a really cool version of set reg value helper.
So could you do that append with the other cons below it? Can you do that exact same thing?
No, because the other one we do need to keep building our list because this other cons here, I made no changes to that to list. I still have something to search for. I need to still find that variable whose value I want to update. So I need to make I need to make another recursive call. Yeah, this guy just says effectively, I found what I need to change, so change it and then just keep everything else the same. Makes it more efficient because I don't have to keep calling recursively. Like if the first register you're changing is bucket 2, if the register you're changing is bucket 2 and you got 700 more buckets, our first version would call 698 more recursive calls only to never find the variable you're looking for because it already found it. This guy will, after it finds it on the second pass, it'll just tack on the rest of the list. Now, let me show you let's call this guy define. Here, I'll steal from up here. Set reg value helper cool. I haven't even thought through this, but I think you're going to just be so upset when you see this. So we're going to have a function. That function is going to So I want to map a function across reg file. That function is going to be a lambda that takes in a list. That's going to be one of our two lists. And it'll ask the question if car, let's see, if it's equal to our guy. So basically the same question we asked before. So if EQ question mark car list, if that guy is equal to our reg name, like that. Now we're going to boil down to our new to list. Otherwise, keep it. So we'll boil down to the list containing reg name and new val. Otherwise, just boil down to list. And we're mapping that onto reg file. So that's the cool version of it. So this should do. So there was T1, there's T5. So that one was a little bit shorter. So what does map do? So map can be pretty powerful, but can also be very intimidating, right? So I wouldn't have expected you to necessarily use map here, but map says apply this function, whatever function I pass in here. So that function had to be very specific. Apply this function to each individual element of this list. And what does this function do? This function takes in a list and he asks the question, if the first element of that list is equal to the guy I'm looking for, then boil down to a new list with the reg name and my updated value. Otherwise, leave the list alone. So if we think about this in terms of this guy up here, if this is my list of two lists, and I'm only updating T1, and I map a function across each of these, I map that function onto this guy, I map that function onto this guy, I map this function onto this guy. For each one of them, it's going to say, is the car of this guy T1? It's not. Leave it alone. Is the car of this guy T1? It's not. Leave it alone. Is the car of this guy T1? It is. Create a list out of T1 and the new value. Is the car of this guy T1? No. Leave it alone. Is the car of this guy T1? No. Leave it alone. And map always results in a list. So this is the map version of set reg value helper. And the only reason, in fact, actually, we could have
It's going to return the whole list though.
yeah, so you didn't even need to do it in a helper. You can just do this as set reg value cool, like this. Yeah, map always results as a list.
Right, but it's where is it knowing that you wanna, so you went through the first one, it wasn't the first one, it wasn't the second one, how does it know to still include the first and second one?
All right, let me show you an example of map real quick, just so you, that's what map does. It applies this function to each individual value of a list.
So it like takes each one but only changes them when you want to change?
Well, in this particular case. But for instance, let's say I have, I want to map the function lambda x times x2. That's a function that takes a single parameter and multiplies that value by 2. And I want to map that across the list 1, 2, 3. What this will do is it'll take this function and it'll apply it to a 1, which will give me 1 times 2, 2. It'll take it 2, yep, so it took this one function and applied it to each individual. So the second parameter always has to be a list. It applies it to each individual value of that list and then gives you the result as a list. So the result will always be a list. So instead of, and here I'm applying it to just individual integer values, where up here I'm applying it to 2 lists. So that's a element, and that element happens to be a list with 2 things in it. And I'm just saying, is the first dude the guy I'm interested in? If it is, make a new to list with the updated value. If it's not, leave it alone. But I mean, it is let's call it a shortcut or something like that. It just happens to embody the logic that we actually needed for this problem. It's in no way required, let's say, but you actually didn't even need a helper for this guy because you would have just left that out. So we'll say set bang this guy equal to whatever map returns. So that's in its entirety the entire update function. Doesn't even need a helper. I'm updating a variable. That's what set bang does. What variable? This is the name of the variable. And what am I setting it to? Whatever map returns when I apply this very special lambda to the old version of register file.
And you're putting for your setting the register file, that's what we made up above, right?
Yep, that's this guy. If you named yourself, if you named yours something different, I mean, that's what I had given you as a starting point, but yeah, whatever your variable that represents your register file, that's the name of the value that should be there.
Can you only use that, like if you make your own, whatever, what do you call that? The register file. Can you only use that in a setbang, or can you use that? Can you pass that in anywhere in a function?
Well, we are passing it anywhere. If you go back to our get register value helper,
Right, but that's,
I mean, we're using it. Where are we at?
we're passing it in,
Yeah.
but that's, I feel like passing it in is different than like using it.
Well, no. I mean, we are using it here. This guy will boil down to its value, which is that list of two lists.
What if you have it in your lambda? Then it's different?
Well, okay, so you mean like up here, I had this helper and I called it reg file, but what if I name it register file?
Yeah.
That would be okay. This is a more local variable than that global one. So now in my scope, I have two register files. One is the global one, but as far as this lambda is concerned, the most local definition of register file is the guy right here. So I injected it into that by passing it from here. This kind of gives it like a pointer to that value.
Follow-up question.
Mm-hmm.
So leave reg file as is. Now, let's say instead of saying car of reg file, you did car register file. Can you use it there?
Yes, but it's not going to give you the result you want. Because if you say, well, it'll give you the result you want the first time.
Well,
Because if you say car of register file there,
change the other one, but
well, but keep in mind, when you're passing this through and you're passing in the cooter of register file, what's actually getting passed in here, you're not changing the global guy. You might say, oh yeah, I'm just passing in the cooter of it, but you're still always referencing register file here, the original variable. Nowhere, these are two separate variables. Let's just go back to that. When I pass in the cooter of reg file, it is saying whatever this guy currently is, whatever his current state is, give it everything but the car. When I'm asking for the car here, I'm saying whatever his current state is, give me the car of that. And the car of that will give you the register name. If I change this, let's just make it wrong. If I say register file like that. So I'm always going to be asking about the first variable name in register file. Every single time. That will boil down to 0 every single time. Because I am passing it the cooter of register file, which is this. And that's what's being passed in as reg file, but I'm never using reg file. Make sense? Okay, so we got two options. We really don't have two options. We're doing two separate things. One thing is we are either going through an existing thing looking for something, or we're building up a new thing with the ultimate goal of finally updating it. But we don't do that set bang. We don't use that global variable until the very end. We use it at the very beginning and we use it at the very end, and in between we pass around its current state as we're making those changes. All right, so this is reg file.
So the wrong one should causing infinitive loop, right?
Yeah, it would, because you're never going to get to null.
Can you go back to math then?
Yeah.
I mean, for that one, you technically, if you would have changed inside the lambda, instead of it saying reg file to register file, and we were still passing in the register file, it would just be a new variable named the same thing.
Yeah, but it really depends on exactly what you typed, because if you passed it in once like that, that's fine. But if you are recursively calling it with a global name, and you don't have a local variable of that, that's a problem.
Well, I mean, like, if we changed the local variable name.
Yeah, the local variable name is called register file. Now you don't have access to the global guy directly. You'd have to do it through your other function that's doing the set bang. Yeah, which is fine. But just make sure you know why it worked. Mm-hmm. Not that, I lucked out and it magically worked. All right, so what are we looking at, the map?
The cool kids thing.
Cool kids.
The
Yeah.
helper.
It's not helper.
And what was down
This is
below?
all in all in one.
You did call a helper down below.
Yeah, but before. Now I changed it to just set reg value cool. And set reg value cool doesn't call any helper.
And your other one.
Yeah, set reg value.
Stop right there.
Oh, yeah.
Reg value.
That guy no longer exists. That'll be an error.
Okay.
Now he calls the original helper.
Okay, so now scroll up to the real.
The real cool one?
Yeah.
Yeah, so this guy's all in one. That is the entire code for updating your register file with a new name value pair. And truth in advertising, I did tell you that one would piss you off. It's like, wait a minute. I spent a day of my life on it.
And you weren't gonna want to see something.
It really wouldn't have made a difference, except you would have just had to do it inside of a single LED environment. You would have had to have a local variable.
Give you an example where, like, let's go back to when you said that we had to use a let rec.
Yep.
Do this assignment using a let rec.
Okay.
Let's go.
Well, I'm not done with the assignment. You want to finish the assignment, or we switch to let recs?
Done? Well, I mean, like.
All I've done is change the ability to look like change our register environment.
No, I just meant that part first. That first part. The set and load. Have we not done load yet? Or?
We haven't done load yet.
Okay.
All we've done is we have written readers and writers for that guy.
They're basically going to
different
be
ways.
helper functions for the store and load and
Yeah.
everything.
But the point is that we could have done, if we were doing this as a let rec, none of our code would have changed, other than this wouldn't be a global variable, it would be a variable defined inside of a let rec. And we would change it, its value would modify along with the state of the current assembler.
I would still like to see it.
Okay. But should we solve the rest of it the other way first?
Yeah, but you promised me that you did.
It is the easier way. It's just it's got more. Well, actually, that's not fair. It's not the easier way. It is probably, well, it is the identical way. It won't make any difference big code wise, but it is probably the more parenthesis confusing way.
I don't care. I just
Yeah,
want
the
to see it.
Yeah. Because with a let rec, you're adding an extra 2 layers of parentheses, so things might become a little bit less readable, but the code should be basically identical. Not even basically, it should be identical as long as you happen to choose the same variable names. So we'll do it. Okay, so I now have a tool that allows me to retrieve the value of a current register, and another tool I have 2 tools that allow me to change the value of a current register. Cool? All right, now the other thing I have is I have this data memory. I'm gonna move that up to the top just so I kind of keep those things together. And I want to do something pretty identical here, right? So,
Wait, you're saying we have to do it all over again?
well, no, not really. I mean, it is what I am doing something
But we need to
basically.
be- for each one, we need to have all the same replicated functions. You can't just use the same one.
You can just use the same one.
Just change the name.
Change the name of it. So I mean, you could just have a single function that says set this thing. So
Right,
I mean, we could do it right now, and just instead of passing our reg file in, we would pass data memory. So I could come in here and I can say, well, I would need to go back to my helper one. Let's go to set reg value, this one. And this guy assumes we're calling register file. I could just pass it data memory, and it would, because that guy's just a list of two lists. So realistically, what we would do here is,
Have another variable.
well, you can have another variable or just have a function that is just a, so we'll call this guy set reg, let's see,
Memory,
I think
let's call this guy set,
data, then
well, just call it set helper. And set helper is going to,
accept,
I'm going to take all these things. So he's going to take in, instead of calling it a reg name, I'm going to call it a var name and a new value. And he's going to, as well as the,
list.
yeah, let's call this the, yeah, list name.
Define should.
Oh, but will this allow me to change that? I think it will. Well, we'll try it.
Won't. My-
Well, you'll see how I'm going to try to call it. I think I'm going to try to call it a different way.
What's the difference between def and define?
Def doesn't exist.
It's spelling wrong.
That's a different language. So this is define. So the logic is going to be identical for these two things. In either case, I'm changing the value of a to list, right? Or getting the value of a to list. So I can create helpers that take in a different to list. So maybe we do it. Actually, you know what? Rather than try to get stupid with this, let's just go back to what we had, and we're just going to do it this way.
Technically, that won't work because the parameter is immutable.
Yeah. So what he's saying, immutable means not changeable. So when you pass in, I was going to have it pass in the name of the variable. It won't allow you to change a global variable given its name from the parameter of a function. So I can't do something like this. I can't say define blah to be a lambda x and then do set bang x to 5.
It's not.
It won't let me do that because x is an immutable variable. It's an unchangeable variable when it's passed into a lambda. It's like the rules of lambda says this guy is locked. So therefore I can't do a set bang in there. So the way to do this is to just do this.
Just using the global.
I'll take this exact same thing here,
Create a new one.
and we're going to define this as set dm value.
Sure.
And this is going to say, let's call this
And
member address and new value.
memory address.
And this guy's name is data memory. Oh, I'm lost. Where am I? Oh, there it is. So we'll set data memory equal to, and we can go ahead and actually call set reg value helper. This is probably not the best function name for this because it's working for any to list. So here we can even do
Set value helper.
set to list value helper. So I'm going to come up here. I'm going to change the name of, I'm going to say this is get to list value helper. Get to list value. I'm just changing the name of this to be more generic so I can use it for anything that's a list of to lists. And we can leave this guy. Well, I'm going to change, instead of reg name, I'm just going to call it name. Instead of reg file, I'll call it file. All right, so this is effectively my core function for getting a value given a variable name from any list of to lists. That's what this guy does. Similarly, so we have get reg value, and I'll steal this. And we have get DM value. And this guy will get the to list value helper, giving it the mem address. And our data memory. Lost. All right, so if we're getting a register value, we'll pass in the name of the register, call your variable what you want. We're going to call get to list value helper, passing it that register name and the list of to lists that we're searching at. For DM value, we're going to take in a mem address, variable name, and that's going to be the result of calling get to list value helper on that memory address and telling it to look inside of our list of to lists, which is called data memory. So now we have both tools for doing it with for getting a value, then setting a value. Here's set reg value helper. So we're going to call this set to list value helper. And this guy will take in a name, it'll take in a new val, and it'll take in a file. If the file is null, return the empty list. Otherwise, if the file matches the name, the car of the file matches the name, append the name and the new value onto the footer of the file. Otherwise, cons the car of the file, the unchanged to list, onto the set to list value helper, passing it the name, passing it the new value, and passing it the file. Now, if we want to update the set to list value cool thing, well, I'm just going to leave that alone. We'll just leave this as an example of yeah, is that cool, or do you want me to, because this guy, we'd have to write two versions of this, one that passed in register file and one that passed in the other thing. So we're going to call this guy set reg value, and he's going to call set to list value helper, and then this guy is going to be called set DM value. And this is going to be mem address, and he's going to set a variable called data memory. Oh, I already started writing this. So he's going to set data memory equal to set to list value helper of our mem address, the new value, and the list we're updating, which is called data memory. And then this is the guy we had started writing that we just finished writing. It's a duplicate. All right, so there's our register file, set reg value beforehand, and then there's our data memory, set DM value, and what do we have, like 5,000? Let's set that equal to 20. That's the name of it's one of our lists, right? 5,000. Okay, so we'll run this. So we see our 5,000 beforehand as a 0, our 5,000 after is a 20, and we already saw our other one work where our T1 was a 0 and then it became a 5. So now we have the tools for reading and writing from two lists with renamed versions of themselves for calling upon the same logic. All right, so far so good? All right. So for right now, let's do this. I'm going to let me paste this code up to Slack, and then maybe take like 5-minute breather. Get your code up to this point if you want to follow along with what we're doing, and then we'll pick up and complete the assignment in terms of these primitives we just wrote. Sound good? But I'll give you this code as a starting point. So I'll put it up on Slack right now. I think it's going to be safer if I stop the recording and upload, and then we'll start a fresh recording.